Hello guys, welcome back. We're still exploring completing square, and today I'm going to show you the second method, how to work out a complete square from quadratic expression. So let's say we have quadratic expression x squared plus 4x plus 5, and we want to figure out how it looks if we have a complete square, x, let's say, plus some m squared, and finally residual number n. So I'll mark those letters m, n, and our goal is to find m and n. Okay, remember before in the previous video when I used this simply through the formula a plus minus b squared, we just hired this formula in order to work out a and b parts in order to see what actually complete the square, which numbers a and b complete the square. And so I'll just do a little recap how we figure out it quickly. So for this reason, because we have plus 4x, we have a middle term with a positive sign, so just simply use the formula with the sum of two numbers, binomial expression, and squared. So according to the formula, we need to have that one. Okay, so do you remember how we did it before? We just simply figure out what a stands for and what b stands for. So obviously, if we compare with our structure, with our quadratic expression, we definitely say that x squared and 4x, that's what we're looking for, and then we start comparing with coefficients a and b. Alright, so for a we have x, because definitely this is the first term, and instead of 2b we should have 4x. Okay, so what to do? We just simply need to rearrange 4x in order to have 2ab structure. So we put 2 because we have 2 in the formula. Instead of a we have x on the previous step, and instead of b we should have the rest part, so that in total we've got 4x. So we're thinking of what we need to multiply 2x by some number in order to get 4x. So obviously it's 2. So b is simply 2, and then we need to have b squared. So we add b squared, which is 2 squared, it's 4, and we immediately subtract b squared in order to don't break the balance. So that's why 4 minus 4 is still 0. And finally, we need to add the rest 5 that we had originally. Okay, and this expression in square brackets is a complete square. And we will get the following finally: x plus 2 squared and minus 4 plus 5 will give us plus 1. Okay, so that's why we arrived. Okay, so what we know? We know that expression x squared plus 4x plus 5 can be rewritten in this form, which is called complete square. But this is method 1, so we used the first way how we can work it out. Okay, today I'm gonna share my ideas about how you can do through the formula. You know that complete square should have something like this form, so similar form with minuses, but for some reason we need to choose the pattern or a sample. So in this case I will use this pattern, and I will say that this expression should have generally the following form: x plus m, which is squared, and in the rest part we need to add another letter n. Okay, that's what we're going to have instead: x squared plus 4x plus 5. So we use some pattern or a sample or the formula. Okay, our goal is to find m and n. So what we can do? We can simply do expansion. We need to expand the right side and we'll have some quadratic expression. Okay, let's do it. So I write x squared plus 4x plus 5, notifying that we need actually from here come to the complete square. But now instead of like guessing what m and n stays for, actually we know from the previous method. But let's let's forget what we're doing before, and let's pretend that we don't know m and n. So our goal is to find them. So we need to expand this expression, and we do it using simply the formula. So x plus m, I'll do it on the side. It will be x squared plus 2xm and plus m squared. So I highlight that m's are knowns. Okay, so that's why we, instead of these brackets, we have this expanded form. Okay, let's write it here. X squared plus 2mx, so I highlight the m's here, and plus finally m squared. And obviously we need to add also n as the rest part. So now we know that we have two ways of how we express our quadratic expression. Express quadratic expression, that's good. All right, so now what we can do, we need to make a comparison. So let's make a comparison. So x squared and x squared is here. So 4x obviously should be equal to 2mx because this is the only x term, a single term on the left side. So corresponding single term that contains only x and the power 1, it's only this term, 2mx. So what we can do, we can say that coefficient 4 just before x should be equal to coefficient before x on the right side. So it looks like from here we set up an equation for m, from where we can determine m. So m is 4 over 2, which is 2. So we've determined m. Okay, but we also have a free term, which is 5, so I circle 5. Okay, where is the free term or free coefficient on the right side? Obviously it's this expression, m squared plus n. So in total, 5 on the left side should correspond to m squared plus n. But because we know what m that was found on the previous step, we simply can plug 2 instead of m. And we can write m equals, 5 equals to m squared is 4 plus n, from where n is 1. This method is pretty straightforward, but so first of all, you need to remember this structure. So because we use some sample, and just apply the formula of the square of the sum in an expanded way, and then compare coefficients of your original expression, what actually you're supposed to turn into complete square, and on the right side, like sort of general expanded form. This method is pretty fast, but I don't know. So some people prefer the first method because it's probably also straightforward. Maybe it works a bit faster if you're able to find quickly A and B. Okay, for those who can memorize what we need to arrive to, you can use method 2 through the formula and through later comparison in order to find coefficient m and n. Okay, so let's maybe practice a little bit, and today I'll give you a bit more complicated expression. So let's take this one and we'll try it out to you to apply the second way. So let's say we have 4x squared plus 4x minus 8. In this case, what's the difference? We have coefficient 4 and in the leading term. Okay, so there are actually several ways how we can cope with that, but I recommend to factorize 4 from that part. If it's possible factorize completely, like in this case, we can do completely. So let's factorize completely. So we factorize 4 and we have x squared plus x minus 2. So the rest part is actually, you need to convert into complete square. So turn into complete square. Okay, so we just working with this part. X squared plus x minus 2 should be according to the pattern x plus m squared m plus n. Alright, so I mark letters that we need to find as m and n, and right now we need to find them. So what we're gonna do, we need to expand that. That's the first step. So expand, and the second step is to compare. Okay, so we have x squared plus x minus 2, and here we just expand it. We have x squared plus 2mx, m plus m squared, and finally plus n. Alright, and let's do comparison. So x squared is this x squared, so we don't do anything, but the middle term containing x should correspond to 2mx. So we can set up coefficient before x is 1, and here's coefficient is 2m. So we can set up an equation where m is 1 over 2. Alright, so having that m is 1 over 2, we compare the free coefficient. In this case, it's -2 equals to the whole expression here, so I highlight. So -2, take into account also a sign, is equal to m squared plus n. So we write that, and instead of m, we just put 1 over 2. So we'll have the following: -2 equals 1 over 4, because we've squared up n plus n. So from where n is simply -2 and 1 over 4. Or you can write as the decimal -2.25 if you like. So we found m and we found n, which is -2 and 25, and m is simply 0.5. So if you like decimals, just put decimals into your final expression. So that's why our complete square will look like we just put back m and n values. So we can write that x plus m 0.5 squared, and simply plus n, which is -225. That what we have instead of complete square. Alright, so this method is pretty straightforward. So you're eligible to use your round methods, so you're not restricted which method to use, either through the formula and through rearranging the middle term that we did here, let's say. Okay, so we rearranged the middle term for x into proper structure to AB, and we worked out a and b coefficients, and through predetermined pattern like x plus m squared plus n. So no matter which letters you use, instead of m and n, you might use a and b. So this is not a big deal. So feel free to use any letters. I'll use m and n. And this method is pretty straightforward, but you need to remember how to expand this expression. Again, using the formula x plus m squared equals to x squared plus 2mx, m plus m squared. So simply then you compare coefficients corresponding terms and work out the values m and n. Alright, so hope you enjoy. Probably in the next video I'll set up several problems, GCSE problems, in order to practice both methods, and I'll just be switching methods in different ways. So just looking forward. So don't forget to share your comments about how helpful this video was for you guys, and obviously so you need to have more practice for that in order to have those methods or one of them in your toolkit. So thanks for attention, and see you later, guys.